Hi everyone. In today's lesson, we're going to talk about a concept called the squeeze theorem. So the squeeze theorem states that if we have three functions where h of x is the smallest, then g of x, then f of x, where x is near a, except possibly at a, and the limit as x approaches a of f of x, and the limit of x approaches a of h of x are the same, and they're L, then the limit as x approaches g of x is also L. So in more simple terms, it basically means if the h of x and f of x, which are the two functions on the outside, so if the two functions on the outside have the same limit, which we'll call L, then it implies that the middle one also has a limit of L. So let's just take a look at a graphical representation of this. Here are our two end functions, f of x, the green function, and h of x, the blue function. Notice how the limit as x approaches a from the left and the right, it's the same y value, which we'll call L. So if we squeeze another function in the middle between them, we call that g of x, it implies that the limit of g of x as x approaches a is also L. So it really makes more sense when you see a picture. So how do I do it when I don't have a picture? So here's an example. It says, let f of x and g of x be functions defined here. And if f of x is a function that satisfies this condition, for all x, what's the limit as x approaches 0 of f of x? So the first thing I honestly would do is take a look at what they give you. They're giving you your g of x and your h of x, which happens to be the ends of the inequality here. So we're going to go ahead and plug in what we know. We know that g of x is 8 minus x to the third. We don't know what f of x is. And we know that h of x from over here is x to the third plus 8. Now, the goal is to find the limit as x approaches 0 of f of x. So basically what I can do is if I'm going to add in the limit as x approaches 0 here of f of x, whatever I do to one piece of the inequality, I have to do to all of the pieces. So I'm going to add here the limit as x approaches 0 of x to the third plus 8. And then over here, the limit as x approaches 0 of 8 minus x to the third. So now we know this is what I'm asking for. Now, the squeeze theorem says that these two end limits have to be equal. If they are, then the middle is in fact just that. So we can actually evaluate these two endpoint limits, right? All we can do here and here is simply use direct substitution. So everywhere I see an x, you're going to put in a 0, which would be 8. Over here, same thing, 0 to the third plus 8, which is 8. So this proves that these two end functions have the same limit. Now, just to write it nicely for the AP exam, we're going to say limit as x approaches 0 of f of x. We're just going to drag this down, and then one more time, the limit as x approaches 0 of f of x. So since we've proved that these two endpoints are equal and their limit is 8, it implies that this limit is 8. So the answer, using the squeeze theorem, is the limit as x approaches 0 of f of x is in fact 8. Okay, let's take a look at the second example. So it says evaluate the limit as x approaches 0 of x sine x. Notice how they don't give you the two functions. So in this situation, you actually have to find those two equal endpoints. And the way that you do that is you want to look at the range of the trig function. So you need to remember from pre-calc how to graph a sine curve. We know that a sine curve starts at the midline and goes up, down, and up. And we know that a normal sine curve will oscillate between -1 and +1. If there's an amplitude, then it would change it, but for now, it just stays -1 to 1. So what this tells us is that the sine of x curve cannot go beyond 1 or less than -1. So what you can conclude from that would be your second step, your conclusion, from the range is that you can say that the sine of x curve is between -1, and 1. And from here, we can build using the squeeze theorem. So here is the limit that I want to find if we add the limit to it, and then these are the values at the endpoints. However, I want to find the limit of x sine x, not just sine x. So just how in the first example up here that I could add a limit to each piece, I can simply multiply each piece by x. Why x? Because I needed this to say x sine x. So we're going to distribute this x to all three pieces. So we'll get negative x is less than or equal to x sine x less than or equal to x. And now we can do exactly what we did here, put a limit in front of each of the pieces. So we're going to say the limit as x approaches 0 of negative x, and then the limit as x approaches 0 of x sine x. And then again, the limit as x approaches 0 of x. So just like we did before, this we can use direct substitution, and this we can use direct substitution. So we're going to go ahead and directly substitute in 0. So this left side negative 0 is obviously 0. This right side 0 is just 0. And again, just for writing it correctly for the AP exam, we're just going to follow and bring down the middle. So this proves, using the squeeze theorem, that the two outside functions have the same limit. So since that's true, the middle will also have the same limit. So the final answer to this question is the limit as x approaches 0 of x sine x must equal 0. Okay, let's go on to the next page. Okay, so one more example, and then you guys can try example number 4 and 5 for homework. So I'll go ahead and put that there now. Homework for 4 and 5. There was a typo here on number 4. This should say instead of -3, this should say +5 at the end, and then everything works nicely. All right, so let's do one more. Let's do example number 3. So same kind of concept. They're giving you two functions, g and h. They're telling you f is a function that's in the middle of these two, and they're defining a specific domain. They're just saying that x must be between -1 and 5. What is the limit of the middle function as x approaches 0? So again, I'm going to go ahead and put in what I have. I have here that g of x is over there, and it is cos of pi over 2 x plus 2 less than or equal to f of x less than or equal to my h of x, which is x squared plus 3. So again, I want to put in a limit. So we can go ahead and do that. We could put our limit as x approaches 0 of cos pi over 2x plus 2. And we have our limit as x approaches 0 of f of x. And again, our limit as x approaches 0 of x squared plus 3. So we can handle the two ends using direct substitution. So here and here, I'm going to use my direct substitution. So let's do the easier side first. Over here, we could plug in 0. So 0 squared plus 3 gives me 3. Now over here, I'm going to plug in 0. So cosine of pi over 2 times 0 plus 2. Now we know that anything times 0 is 0. So this is really asking you to find cosine of 0. So you need to have in the back of your head a nice little unit circle. But I only care about it at 0 degrees or 0 radians, which happens to be here, and that's the point 1, 0. So cosine of 0 is the x value at 0 degrees, which is 1. So now we have 1 plus 2, which gives us 3, same as before. So we can go ahead and now, unfortunately, it's going to take a little bit of our steps here, but this is equal to the limit as x approaches 0 of f of x. Again, limit as x approaches 0 of f of x. And unfortunately, one more time, the limit as x approaches 0 of f of x is less than or equal to 3. So this tells us that we can squeeze in this limit as x approaches 0 of f of x, and that answer is 3. So final answer to the problem is the limit as x approaches 0 of f of x is equal to 3. Alrighty, why don't you guys take a minute, try example 4 and 5 for homework, and then we will go over both of these in class tomorrow. All right, have a good night.